There are actually a few terms I want to introduce to you. The first one is vertex. Okay, vertex is the orange color. Okay, vertex is the orange color that you see in here. And there is another term that I want to introduce, which is the edges. Okay, edges. If it is an undirected graph, okay, if it is an undirected graph, right, meaning A can travel to B, B can travel to A. This is a undirected graph. Okay, and it can be weighted. Okay, if it's weighted, right, so in the edges we can store the. It's not a real edge. This is just a like an imaginary line only. Okay, this is like an imaginary line only. So we can store a value. Okay, we can store a value inside lah. Okay, so it can be rated. When you call the original addEdge, right? Okay, don't use an addEdge. I will recommend you to change the name become addVertices. Okay, addVertices. Let's say we add AB. Okay, when we add the AB, we actually call AB like this. Okay, if we read the input, we read the file input AB, we'll call the addVertices. Okay, addVertices like this, and then this addVertices will first call the addVertex. Okay, this addVertex, right, will look at the vertices list. Okay, let's draw our vertices list. Okay, our vertices list initially is empty. We find first. Okay, we find A. Is our vertices list contain A? If our vertices list don't have A, right? Okay, then we insert a A in here. Okay, we want to find B. Okay, we add vertex B. Then we find the vertices list. Is there a B? If there is no B, right? Okay, we insert B in here. Finally, right, we want to do this because it's a directed graph. Okay, because it's directed graph, we want make A connect to B. Okay, we want make A connect to B. So in the A, okay, in the A you see in here is a graph vertex. Okay, it's a graph vertex. It's a class. Okay, this is a class. This is a class. Okay, this is a DSAGraph vertex. Okay, this is a DSAGraph vertex. As you can see inside the DSAGraph vertex, right, we got another linked list. Okay, we got another linked list because it's AB. Okay, because it's AB, right? A direction go to B, okay, A direction go to B. So our A direction or A direction we refer. Okay, we refer the B. Okay, we refer the B. Okay, we refer the B in here. So the light green. Okay, the light green that you see in here, right, is the adjacent linked list. Okay, from the first one, we want to call the addEdge. We call the addEdge. We addEdge what? We addEdge the B. Okay, actually I like the name edgeLinkedList. edgeLinkedList is not bad also. I don't want this one. I don't want this one. So this one is actually edgeLinkedList. Like this. This one is edgeLinkedList. We got a private class field. Okay, vertices list. So private DSALink list. Vertices list like this. Okay. And then right, we have addEdge. We don't use the addEdge name. Okay, we write it as addVertices. So we have a, let's say, public method. Okay, public method. We have a public method of public. The data type is void. Okay, void of addVertices. Okay, addVertices. Okay, addVertices, and then followed by the string name. Okay, string name. Afterwards, right, we call our addVertex. Okay, we call our addVertex. This addVertex, right, will return. Okay, will return our DSAGraph vertex. Okay, inside the DSAGraph, we have a private inner class. Private. Okay, we have a private inner class like this one, and then we want to create this method. Okay, this is simply a DSAGraph vertex like this one. After we insert v1, and then we insert vertex 2. Vertex 2, we insert the label 2. Okay, the second label. Okay, the second label. Okay, second label. After we done this, okay, after we done this, right, then our v1. Okay, v1, we want to call v1 dot the graph vertex inside this DSAGraph vertex, right, we want to call addEdge. We call addEdge v1 dot addEdge the v2. Okay, we add the v2 like this one. Can you understand? Vertex edge link, and inside here we have a edge link like this one. I give you a skeleton. Okay, I give you a skeleton already. Owner is addEdge. Can further. Actually, you got a method to get vertex first. You got get vertex. You got a get vertex equal to get vertex of the vertex name. Okay, like this one. Okay, this is the add vertex. When you want to add a vertex, right, you go and find first. Okay, you go and find whether there is a vertex. Okay, whether there is a vertex. You check whether the vertices space contain the DSAGraph vertex. So if there is no vertex, then we add a new vertex to the linked list. Okay, vertex is the dot. Vertex is the light green color, or you mean the edge. If you want to add vertex, you use the addVertices. This one, you add the addVertices like this. You add vertices AB. You add vertices AB like this. The old name is addEdge. Okay, the old name is addEdge. You use this one, DSAGraph. In your DSAGraph, you call the addVertices, you addVertices the A, then this one, you addVertices, you call the addVertices, you call addVertices A, you call addVertices of the B like this one, B like this one, okay? Then draw it to a diagram, like this one, like this one. When I draw it to a diagram, right, then only I realize, yeah, the input file is actually given a directed class. So you don't need to v2 addEdge v1, okay? No need. How to output the adjacent list, okay? Let's do a little practice. So let's look at this example, okay? Let's look at this example. If we have a graph, okay, let's say it's undirected. A, B, C, D is have a edge like this, okay? Let's do the exercise together. If you want to get the adjacent of A, what is the adjacent? Adjacent mean neighbor, okay? Adjacent mean neighbor, okay? Adjacent mean neighbor. If I ask you print the adjacent list, I ask you print the adjacent list, then first you want to list out the available vertex, okay? The available vertex is A, B, C, D, okay? You have vertex A, you have vertex B, you have vertex C, you have vertex D. So from vertex A, what is the adjacent? Adjacent got D, we got C, we got B, correct or not? Then we write B, C, D, like this, okay? And then let's look at B. What is the B adjacent? B adjacent is A, okay? B adjacent is D, B adjacent is C, correct or not? Then we write the adjacent as A, C, D, okay? So let's look at C adjacent, okay? What is the C adjacent? C adjacent is A, B, D, okay? So we write A, B, D, okay? Let's look at D adjacent, okay? D adjacent is A, B, C, okay? D adjacent is A, B, C, okay? So with this, right, okay, with this, we completed the adjacent list, okay? So when you want to print your adjacent list, it's just like this, okay? Don't think about the code's perspective first, I tell you, okay? Okay, if you want to write it manually, how should you write, okay? When you know, okay, when you very clear already, okay, when you very clear how to output this, then only, okay, then only go and think, okay, think about the code perspective. You know you need to iterate through the vertex first, correct or not? Then you go to the vertex first, you go to the vertex, okay, you go vertex A, okay, you go to the vertex. Remember in the linked list just now, okay, in the linked list just now, you go to this vertex first, go to this vertex, then print the adjacent, print the adjacent. That's why previously I call it as adjacent linked list. Let's say you want to implement adjacent matrix, okay, better do it now. Actually, it's not too hard. Then you write A got B, A got C, A got D, okay, this is 1, 1, 1, 1, okay, 1, 1, 1 like this, okay. Then you look at B. B got what adjacent? B got adjacent A, B got adjacent C, B got adjacent D, okay. B got adjacent A, B got adjacent C, B got adjacent D, okay. And then you look at C, C adjacent is A, B, D, right? Okay. C adjacent is A, B, C got D, okay. And then D got A, B, C, right? Okay. D got A, D got B, D got C. Then the remaining of the matrix is 0, 0, 0, 0. Okay. This is the adjacent matrix, okay. So because you don't need to care about 0, because when you initialize the matrix, right, integer by default is 0, okay. So you only need to fill in the adjacent only. Fill in the adjacent, fill in the adjacent. Give you a hint, okay. Give you a hint. You need 2D array. You need one 2D array to solve the adjacent matrix, okay. Let's look at directed graph, okay. Directed graph meaning there is a direction, okay. There is a direction. If you want to solve, okay, if you want to solve directed graph, what is the adjacent of A? Okay, let's look again. Adjacent of A is D, C, B only, right? So we write, okay, B, C, D, okay. What is the adjacent of B? Okay, adjacent of B is only C, okay. Adjacent of B is only C, okay. So we write C only, okay, we write C only. And then what is the adjacent of C? Then we look, C have no adjacent, okay. C no adjacent, okay. C don't have any adjacent, And then let's look at adjacent of D, okay. D got what neighbor? D got what neighbor? D don't have this one, D cannot see here. D cannot see A, okay. D can only see C, D can only see B, okay. D can only see C, D can only see B. So D is BC like this, okay. After you finish, okay, after you know how to visualize it, let's draw it to a adjacent matrix. So it's a B, it's a C, it's a D. So B is actually C only, okay. C don't have anything. And then D is actually B and C, okay. The remaining one is 0, 0, 0, 0, then 0, then 0, then 0, then 0, 0, 0, like this one. Okay. Therefore search, I think do it in the end. Okay. Do it in the end. First, you need to able to print first. Okay. You need to be able to print first. Write your display as list method first. After you've done, okay, after you've done, then only you write the depth first search and breadth first search. Okay. DSAGraph vertex. You can name it as adjacent linked list. Okay, you can name it as adjacent linked list. You can also call it as edgeLinkedList. This one, I leave it up to you. Okay, because when you want to print, okay, when you want to print your adjacent list, right, this BCD, okay, this BCD that you see in here is actually the edge. Okay, what you call as edgeLinkedList, okay, what you call as edgeLinkedList. This one, okay, what you call is the edgeLinkedList. Okay, and you got a addEdge method okay, you got addEdge method, and you got get label, and then there's a get wet. This wet is just for storing the wet, okay, and then pop adjacent you don't need to write. Okay, no need to write the pop adjacent. And then you want to have a get is visited. Okay, the get is visited is just a boolean, okay, boolean variable. This is visited is also a boolean. You got a class field called as is visited. You need this class field. Okay, you will need this class field. This class field is so important, I tell you, very important. This is visited, right, is used in your breadth first search, and also your depth first search here. In your process breadth first search and your process depth first search, right, you will use this boolean. Okay, you will use this boolean because your graph is like this. Okay, your graph is like this. When you want to get all the path, let's say we have a graph of ABC. Okay, we have a graph of ABC like this. Then the connection, let's say, is like this. Okay, let's say if there's no error, if ABC, I want to get all the path. Let's say I want to get all the path from A to C. If I want to get all the path from A to C, right, so I want to A, then set B as visited, and then set C as visited. So I get ABC as my result. Okay, next, in the next cycle, right, then if I check if this is visited, I don't want to travel it again. So I just travel from A to C. Okay, this is one of the reason why you want a boolean. Okay, this is one of the reason why you want a boolean. Okay, and lastly, you want to, I told you, you need to write the breadth first search and depth first search inside here. If you write your breadth first search and depth first search inside here, it's easier for you. Okay, easier for you to deal with. And lastly, you want to print, okay, get the adjacent list. Okay, get the adjacent list from here. Okay, pass here to here. Okay, pass here to here so that you can print the, where is it already? Display as list. Okay, you can print the display as list like this. So I get my print adjacent label list, print color, this thing, okay, this thing, okay, this BCD, okay, this BCD, right, I actually do it inside here. I do it inside here. Okay, I do it inside here. If you do it inside here, it's easier. Okay, it's easier. That's why I have a method. Okay, I have a method for get my print adjacent list. Okay, then I pass it to here. Okay, that's a tiny tips for you. Okay, like this one, done. We have finished discuss our DSA graph. In your DSA graph, right, print the display as matrix. Okay,